Let us study the electrical energy production by using natural gas. For the production of electrical energy from natural gas, there will be different chambers. The first chamber I am showing you here. This chamber will be the combustion chamber. Think that there will be a container. Now to it, from here as well as from here. From here, highly pressurized air we have to pump it. Air we have to pump it inside. At the same time, from this side or any other side, we have to pump natural gas inside. So here now we are using three chambers. This is the first chamber. This is the combustion chamber. Combustion means a burning purpose. We are using a container. Then towards this combustion chamber, we are pumping natural gas from this chamber to this chamber, and highly pressurized air we are pumping inside. As a result of it, here burning process will take place. So here the burning of natural gas will take place. As a result of it, from here gas will come out. It will be very hot gas. This gas will rotate the turbine. As a result of the rotation of this turbine, generator will start to work. Once generator will start to work, there will be the production of electrical energy, or we can say that electricity. As and when the hot gas hit on this turbine, the turbine starts to function. At the same time, there will be the emission of hot gases. These hot gases are highly dangerous to the atmosphere. As a result of it, there will be the formation of global warming. Or we can say that as a result of the emission of hot gases or warm gases create global warming in the atmosphere. Let us study the electrical energy production by using water. As you all know, we are getting water from rain. That water we are storing and keeping in the water reservoirs like dams. The electrical energy production is taking place from the hydroelectric station, allowing the water from the dam to fall on the turbines. As a result of the falling of water through huge pipes from the dam, making the turbines to rotate. As a result of the rotation of the turbines, generator starts to work. As and when generator starts to work, the mechanical energy producing by the turbine converts to electrical energy in the hydroelectric power station. Now we will study electrical energy production with the help of windmill. Windmill itself is acting like a turbine. Whenever wind blows, the windmill starts to rotate. You all might be seen windmills. Many villages now producing electricity with the help of windmills. For investing windmill, we have to spend large amount of money, but after that, electrical energy production is happening without the expense of any money. In windmill, there will be 3 blades, and windmill is fixing and keeping on tall pillars or tall supports. As and when wind blows, windmill starts to rotate. The windmill will have 3 huge blades. As and when the windmill rotates, with that connected condition, a huge pipe will be there. That pipe is known as shaft. As and when the blades of the windmill rotates, even this huge tube or pipe, that also starts to rotate. As a result of it, generator starts working. Once generator starts working, it will produce electrical energy. This electrical energy utilizing for either household work, or we can say for pumping water in the farmland. Now we will study different flowcharts showing that electrical energy production from natural gas, water as well as wind. The first flowchart, that is arrangement in power plant based on energy of natural gas. For that, compressor for pressurized air as well as natural gas pumping inside the combustion chamber. As a result of burning of natural gas inside the combustion chamber, gas turbine starts to rotate. As a result of the rotation of gas turbine, generator will start. As a result of the starting or functioning of generator, electrical energy will produce. Now, second flowchart, that is transformation of energy in power plant using energy of natural gas. Here, chemical energy of natural gas converted to kinetic energy generated due to combustion of natural gas. As a result of it, kinetic energy, that means turbine starts to rotate. As a result of it, generator will start to function. As a result of it, electrical energy will produce. The third flowchart, which is showing that different stages in hydroelectric power plant. Water reservoir with potential energy. Here inside the dam, the water which we are storing and keeping, that is having potential energy. That water is not having any movement. So we are considering it is having potential energy. This energy converts kinetic energy in the turbine. As a result of it, turbine starts to rotate. When turbine rotates, generator starts to function. Once the generator starts to function, there will be the production of electrical energy. Now we are studying the other flowchart, in that energy transformation in hydroelectric power plant. Here potential energy of water converts to kinetic energy in flowing water. As a result of it, turbine starts to function. As a result of it, kinetic energy is producing in turbine. As a result of it, electrical energy is producing when generator starts to function. Now we are going to study the other flowchart, which is showing that stages in electrical generator using wind energy. Wind with the required velocity. That means inside the windmill there is a gear connection. That gear allows the required quantity of wind to flow towards the generator. As a result of it, required quantity of electrical energy production will take place. Now here, wind with the required velocity makes the wind turbine to rotate. As a result of it, generator starts to work. As a result of the generator or the functioning of generator, production of electrical energy will take place. Now the last flowchart, which is showing the transformation of energy in an electric generator using wind energy. Here, kinetic energy in wind. That means wind is having kinetic energy as it moves always. As a result of it, turbine starts to get kinetic energy. Turbine starts to move, moving energy of the turbine. As a result of it, generator starts to work. Once generator starts to work, there will be the production of electrical energy. Now we will study how electricity can produce from solar energy. For the production of electricity from solar energy, we have to use a special type of cells. Those cells are known as solar cells or photovoltaic cells. Solar cells are made with the help of a semiconductor. It is known as silicon cells, or with the help of silicon element these solar cells are made. If 1 centimeter square dimension is there, such a solar cell or silicon cell can produce 30 milliampere current. At the same time, it can produce 0.5 volt, or we can say that potential difference of 0.5 volt. Suppose if we are making the size of this solar cell 200 square centimeter, it can be able to produce the current of 30 into 100 milliampere. It means 3000 milliampere, or we can write as 3 ampere current. A means ampere. At the same time, the potential difference will remain same. That is, even if the area is more, here area only 1 centimeter square, it means length 1 centimeter and breadth 1 centimeter. Here the same solar cell we are making, or we are converting its area into 100 square meter, the square centimeter. That means length 100 centimeter, and breadth 100 centimeter. As a result of it, the production of current will be equal to 3 ampere. At the same time, the potential difference remains constant, that is 0.5 volt. So from this we can understand that potential difference is independent of the area of the solar cell. Now, if we are connecting the solar cells of 100 square centimeter area one after other in series, the current production will be, suppose this is, we can say, the consider as I1 current production, this we are counting as I2 current production, then total current production by this combination will be equal to, that means total current production I written as I, that will be equal to I1, again that will be equal to I2. That means total current production in this combination will be same. At the same time, potential difference in this combination will be the sum of, that means V is equal to, total potential difference will be equal to V1 plus V2. So, if we are arranging these solar cells in series, the total current production will be equal to the current producing by individual solar cells. At the same time, the potential difference producing by this combination will be equal to the sum of potential differences producing by individual solar cells. Now, suppose if we are arranging solar cells parallelly one after other, the total current production will be equal to I is equal to I1 plus I2. At the same time, total potential difference will be equal to the individual potential difference producing by this combination. So, here the problem is occurring, if you are connecting and keeping series, potential difference will be added but current will remain constant. If you are arranging these cells in parallel, current will be the addition of solar cells. At the same time, potential difference will remain constant. Keeping this in mind, in solar panels, solar panel means number of solar cells connected one after other in series as well as in parallel way. So here these solar cells connecting in parallel way, this is in series, one after other, such a way connecting, we can say that series way, and connecting it in parallel way. As a result of it, required quantities of potential difference as well as current can be able to produce. Now here, if you are making or if you are connecting 36 solar cells in parallel as well as series way, we can be able to produce required quantities of potential difference as well as current. number of solar cells or photovoltaic cells, if we are arranging in series as well as parallel condition, we can make a solar panel. Here now, in this way I connected 6 solar cells. In this way again I connected 6 solar cells. As a result of it, total combination of 36 solar cells I made. As a result of it, we can obtain required quantities of current as well as potential difference. Here each cell is producing current of 3 ampere. Then total we are using 36 cells. As a result of it, we will get a combination of a large quantities of solar energy, or large quantities of current production is possible. So 36 cells into 3, 3 6 are 18, carry 1, 3 3s are 9, 9 plus 1, 10. We can say that 108 ampere current can be able to produce with the help of this combination. At the same time, with the help of this combination, we can produce the potential difference of 36 into 0.5 volt. As a result of it, we will get 18 volt of potential difference. Such a arrangement of solar cells known as solar panel. Same way, such a solar panels, if we are arranging one after other in series, then it is known as solar string. If we are arranging solar strings parallelly, then we are saying it as solar arrays. Now this is one solar panel. Now one after other, if we are arranging solar panels, we are calling it as solar string. Now such a solar strings, one below the other, if we are arranging, that is known as solar arrays. The electrical energy producing by solar cells are DC current. DC current, its full name is direct current. Using this direct current, devices like calculator, and light emitting diodes, or we can say that LED bulbs, works. One more problem, solar energy is not available always. So whenever it is available, that time we have to store it and keep in the batteries. Solar energy devices are few. Even we can say that in our domestic purposes, as well as industrial purposes, we are using AC current. So, this DC current which is producing by solar cells can be converted into AC current by using a device. That device is known as inverter. As a result of the use of inverter, the electrical energy or the DC current which is producing by solar panels can be converted into AC current. Now we will study how thermal power plant works. In thermal power plant, there is one concentrator which is having the capacity to collect solar energy. The collected solar energy by the concentrator is absorbing by an absorber. That absorber can boil the water and converts the boiling water into steam. The produced steam can be able to work or rotate the turbine. As a result of the rotation of the turbine, generator will work. As a result of the working of generator, electrical energy can be produced. We will study few flow charts. First we will see energy in sunlight. How much energy is producing by sunlight? With the help of photovoltaic cell, absorbs and converts the solar energy to electrical energy in the form of DC power or DC current. Now second flow chart which is showing that conversion of energy generated by the cells to AC form, or we can say that how the conversion of DC current to AC current is taking place. Its steps shown here. Solar cells which produces DC current that is storing inside the battery, and with the help of inverter, the DC current which is stored in the battery converted to AC current. Now we will study what are the different stages in the production of electricity by the help of solar power plant. Here concentrators for collecting sunlight, absorbed by the absorber. As a result of it, water gets heated, then boiled. After that, the steam which is coming from it runs the steam turbine. As a result of it, the electric generator starts to run. As a result of it, there will be the production of electric energy. Thank you.